We are now in the topic number 3, and our topic number 3 is called logarithms and exponential. So what is logarithm, what is exponential, and how do we apply it in our daily lives? You apply a lot of logarithms when it comes to, earthquake activities, how to measure these things, and exponential, that uses exponential when you learn compound interest, when you learn population growth of something or population decay of something, you'll be seeing all of these, exponential terms. Before we move on, I want to show you how the graph looks like first, yeah? So this is logarithms, y equals log x base b, and the red one is an exponential, y equals to b power of x. As long as b is a non-negative number and also greater than 0. And if you could see the graph, there's a relationship there, right? They're actually mirroring each other in y equals to x. So if you see y equals to x as a mirror, then they are image of one another, basically. Yeah. So a few properties: logarithm of 1 base b is equal to 0. This is another way of saying it, that b power of 0 is equals to 1. Logarithm of b base b is equals to 1. This shows that b to the power of 1 equals to b. Yeah, you could see it from here, basically. Yeah. So by definition, log y base b equals to x can be rewritten as, or by imply, that b to the power of x equals to y, where b has to be greater than 0, like I mentioned earlier. Let's look at the powers of base 10. Like for example, if 10, this is 10 to the power of negative 3, 10 to the power of negative 2, this is 10 to the power of negative 1, this is going to be 10 to the power of 0, that's going to be 10 to the power of 1, 10 to the power of 2, and so on and so forth. Now, these are the powers of 10. 1 over 1000, 1 over 100, 1 over 10, 10, and 100. And for logarithms, you just basically kind of like rewrite it like this. You can safe to say that, hey, this is a geometric progression. You've learned what geometric progression is, and this is an arithmetic progression. So the whole idea of logarithm is like changing this powers, or this geometric progression, yeah, of ratio 10 basically, right? And then you change it into a logarithm with a difference of 1, right? Minus 3, minus 2, minus 1, 0, 1, 2. And it makes a large number computation, it makes it a lot more easier. So that's why you can see it in earthquake, because earthquake, Richter scale, is a huge magnitude actually. But we simplify it and we call it as 5.8 Richter scale. But actually it's bigger than that, or 6.8 or 6.2. It's actually not a 6.2 in terms of decibel, but it's bigger than that. Now, we are going to be using a lot of natural logarithm. It happens if the base is e, yeah? So log x base e can be rewritten as ln x. Well, it is a Napier constant, so John Napier creates it, or discovered it, basically. So an e, this is the formal definition or formal meaning of what e is. Yeah, that's the sum of from of 1 over n factorials from n equals to 0 up to infinity. So you can also rewrite it as 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorials plus 1 over 3 factorials, and so on and so forth. This is going to be 1 plus 1 plus 1 over 2 factorials plus 1 over 3 factorials, and so on and so forth. And this is how you write it in a 14 decimals. It's 2.718288182845904. E is a constant, E is a number. It is irrational. I'm pretty sure that you remember what irrational is. And E is also a transcendental number. If you would like to do some research about what transcendental number is, then go ahead, give it a try. So I'm going to move on to the few laws of logarithms. Yeah, there's actually only 3 laws of logarithms. We got a additional law. So log b xy, yeah, this means that, hey, you multiply this, then log x base of b plus log y base of b is the equivalence. Yeah. Now, same thing with this. If this is a multiplication and if it's a division, then it's a negative here. Yeah, it's a subtraction. And log bx equals to log bx to the power of n. So kind of like, it drops down here. Giving an example, yeah? Log base of 5 of 45x. So you know for the fact that, hey, it's going to be log of 5 times 9 times x. This is going to be equals to log base of 5 plus log base of 5 of 9 plus log base of 5 of x. So that's going to be equal to log base of 5 of 5. Looking at this gets you a 1 plus this is going to be, well, and that's going to be log 5 of x. And that's as easy as you can get. Now you can use and find this in your calculator. You'll get, many decimals, yeah. And remember, always try and use 3 significant figures as much as you can. How do you simplify this? Well, it's a subtraction here, so you'll use the second law, right? So this is going to be equals to, well, x over x squared, which is equal to ln 1 over x. You can rewrite it like this. This is actually the same as ln x to the power of minus 1 or negative ln x. So there are many variety of how you can rewrite this, right? And they're all the same. Last thing, 3 log 5. Okay, let's just try this real quick. So if we want to make it we want to simplify this, and log 5, 15 to the power of 3, and then that's about it. Okay, another example. A change of base. Log of x base of b is equals to log of c, another base of x, over log of another same base of b. So let's say, for example, we want to change log base of 2 of 15 into base 5. So how do you do that? Well, it's quite easy, right? So, this log base of 2 of 15, that's going to be equal to log of, well, we want to change it to 5, so log of 5 of 15 over log of 2 of 5. So that's as easy as you can get, right? Well, as a matter of fact, you can just use your calculator to get the answer and to check if it's correct, if it's the same. So it has to be the same.